some guidance and some case studies, but anyone who wants a deeper dive into the kind of more traditional build, I can certainly do that at a later stage. So we'll come to questions at the end. So who are BE-ST? We are Built Environment Smarter Transformation, formerly Construction Scotland Innovation Centre, bit of a mouthful. And our job is to basically connect the public sector, industry and our academic partners to collaborate on projects which deliver zero carbon. So it means in practice, anyone who works in the public sector, who's an engineer, an architect, main contractor, subcontractor, product supplier, who's involved in policy, anyone at all can come to the centre and get advice either on technology that's available in construction, on collaboration projects. We can also fund projects. We can fund academics to work on projects. And we have an amazing innovation factory. So if you're looking for help around zero carbon and you're not just sure where to start, then BE-ST is where you would come. We do it across our connected ecosystem, which is essentially our network. So sometimes companies don't really know where to start if they're looking for funding, or they have an innovation idea or a new product that they want to try and bring to market. So we will help them get to the bottom of who they need to speak to. Myself, I'm involved in the collaborative projects and programmes. So we run a number of initiatives here, the Transforming Timber programme. We delivered the Low Carbon Learning Skills programme. We've got the Dive In Diversity and Inclusion programme. And we also do a lot of work with schools, colleges and a number of public sector partners. So we do a lot. We've also got an amazing innovation factory. If anyone's not been, please come along. I'd love to show you around. It's myself that does the tours. And we also have our Future Skills programme. So we're divided into 4 teams. The digital team look at things like drone technology, building information management, digital tools, digital design. Modern methods construction is that whole industrialised methods of construction, so not working out on site, it's building panelised, volumetric whole house systems in a factory-based environment, rather than all the materials, everything get built out on site. You build it in a controlled environment, and there's lots of design efficiencies and material efficiencies that you can make. The retrofit team is where I work, so it's looking at that whole movement towards reducing energy demand in the buildings that already exist. And sustainability is where we look at embodied carbon, the circular economy, design for deconstruction, reduction of waste. So it's anything really that comes under the sustainability banner. Which has got podcasts, webinars, lots of different cases, really easy to access. We also have about to start building the National Centre of Excellence for Deep Retrofit in Scotland. And we also do a lot of training. So we've actually got 4 retrofit rigs in the factory, and you can actually come along and get that kind of practical element of how cladding looks, what are the details in terms of thermal bridging. We've got some really cool AR and VR that you can use, so we kind of use that digital element. And we obviously make the connections with academics. So if you've got a project that might have use for an academic, then we can actually fund that. I thought it was really important to mention the policy landscape. So why is retrofit so important? And there are a number of them. So if you're kind of early stage in your career in planning and you don't know why we're doing what we're doing, these are all the different policies that currently exist. This is where our business plan aligns to. And I think if you've got a bit of time on your hands, then these are really good documents to look at, particularly the heat and building strategy. It's not the draft anymore, that's been published. But I've kindly taken the time to look at some of the targets from the heat and building strategy, and this is why we're looking at retrofit. Why it's such a movement towards it is because we need to do something about the energy demand in the buildings that already exist. In particular on the domestic side, we have to make sure all the millions of homes that exist in Scotland are at an EPC level of EPCC by 2033. That's a huge undertaking. And we also need to make sure that our homes and buildings are moving towards using non-direct emissions heating. So It's 68% against 2020 levels. So again, we have to go from something like 3,000 heat pump installations a year to 300,000 in the next decade. So how are we going to do that? And there's a lot of guidance and a lot of initiatives that we're taking here to help us get there. So you hear a lot in retrofit about fabric first. And essentially, heat pumps are not efficient in drafty houses or drafty buildings, and we've got a lot of them. So when you're thinking about retrofit, you really need to think about the whole house and the installation of the building first. And you'll hear a lot about fabric first, and it's essentially making sure that you've got an airtight fabric to work from, to then utilise different strategies in terms of your heating and your renewable energy sources. So there's lots of different retrofit definitions. People like to think it's responding to climate change. It's about bringing in introduction of new materials, new products and new technologies. But essentially, we want to make sure that the buildings we have are airtight and that you have good indoor air quality and that they're reducing their energy demand. That's essentially it for any building. The current measures that are taking place, it's a single measure at a time. It's not really taking into consideration what the whole house needs, and you can do a lot more in terms of a whole house approach in terms of reducing your energy demand. It also saves money and it makes sure that you're thinking about the longer term approach in terms of financing. So the guidance that I wanted to speak about today is a general overview. If any of you would like more of a deeper dive, just let me know and I can run a training session on that. I just didn't want to overwhelm people with technical guidance, but these are all of the current retrofit standards that you can work through. The LETI climate emergency came from a project down south in London, and it's looking at 4 different archetypes of buildings that you can retrofit, and they've come up with a standard for each of those building types. Now that's on the new build side. LETI then looked at the retrofit, and what they've come up with has got, I think it's 6 different housing archetypes. The Quick Start Guide is a good place to start, and it's essentially about setting targets and a process for how you complete your retrofit project. The Retrofit standard for retrofit is an entire certification process. It's an online certification process, and it's the Passive House version for retrofit. So Passive House is a low carbon design standard. It follows fabric first, air tightness, thermal efficiency guidance, and concentrates on solar gain. And Retrofit is the retrofit version of that. You're not going to achieve Passive House levels. So Retrofit is a slightly more relaxed version of Passive House. The Association of Energy Conscious Building also have a retrofit standard, and it's a slightly less onerous space heating demand target of 50 as compared to the Retrofit target of 25. Energy Strong is an industrial retrofit solution, and it's looking at a series of houses where you actually put a panelised approach onto the outside of the housing, put the roof on top, and it's a shared energy. So tenants who sign up to the Energy Strong model have to sign up to a shared energy plan, and that affects the finances of how the whole scheme is funded. Now, there's problems with Energy Strong in terms of supply chain currently in Scotland. We just don't have the supply chain to be able to supply the panels that's required for the Energy Strong, but there's some really good case studies in Nottingham and Exeter where they've got a bit more of an advanced supply chain, but that is generally something that BE-ST are looking at, that we're trying to work with companies to look at how we can get the supply chain. And it's more of a retrofit scale because it's for medium size to larger scale residential. I've mentioned the Net Zero Standard public sector building standard, which is new build, because they are currently working on a retrofit standard for all public sector buildings. The new build standard is where to start. It's where a lot of all the funding will be attached to in the future. And if you want to understand the buildings as they are currently, this takes into account embodied carbon, operational energy, the post-occupancy evaluation of the building, And it's just a really good resource, and it will be a lot of the same standards for the retrofit standard that's going to come out. The bottom two guidance is for historical buildings. So the energy retrofit short guide is from HES. So no doubt that they would have talked about that if they'd been here today. So again, just a really good reference tool and guide. Traditional buildings are harder and more expensive to retrofit because of the materials that the buildings are made from, because of the aesthetics, because of the architecture that we're trying to preserve. And there's just no getting away from that. We are working on a number of products which can be used in historical buildings, but we're at early stage innovation, so they're not ready for the mass market yet. But if anyone's wanting to keep ahead of what's coming up, certainly get in touch with us. The STBA have also got some really good guidance on their websites as well for anyone who's dealing with historical buildings. But the short answer is there is no short answer. As we do more and more retrofits of historical buildings, there'll be more knowledge to share. And again, I've got some case studies. There's case studies on our website if you want to have a look. So essentially with housing, you need to start with your building stock. You need to start with doing a survey of what you already have and what materials it's made of and what repairs are needed. You can't retrofit a building if it's in a bad state of repair. So that is your first step, I would say. There are a number of digital techniques that can help you with this, modelling techniques and drone technology, thermal imaging surveys. A local authority asked me this week what digital applications exist to help with retrofit. I've got a massive list. So again, happy to share the information. You then want to look at your installation, the windows and air tightness and ventilation, and then your heating system. So it's that step-by-step approach, and all of the retrofit standards that I've mentioned look at a whole systems approach. So you want to take into consideration how each of these interventions are going to work together and what are the financial implications of that. I wanted to mention PAS 2035 because there's a bit of confusion about what it is. PAS 2035 is how you manage a retrofit project. This is the standard by which you can undertake a project to ensure that there's tenant engagement. It's about the health and the happiness of the person who's inside the building. It takes into account indoor air quality, building monitoring and performance after it's taken place. And it's a really robust measurement and guidance. It has been mandated in England. So all of the funding for social housing must use PAS 2035. In Scotland, it's not mandated yet. However, lots of public sector contracts require you to use PAS 2035 to get funded. So I have done the training with Retrofit Academy. Elmhurst Energy also do training around retrofit and all the different roles. But this is the direction of travel within retrofit to ensure that we're not having those horror stories that everyone hears about with mould and condensation and unintended consequences. If you follow the PAS 2035 route, these are massively, massively reduced. But I've also heard it described as a sledgehammer to crack a nut. So it may be that we come up with a Scottish version. All of these conversations are kind of ongoing at a policy level. What I would say, PAS 2035 is different from PAS 2030. PAS 2030 is the guidance that you use for installers. So if you're installing insulation, you have to follow the PAS 2030 installer guidance. And this is just what I lifted from the LETI retrofit guidance. It just shows you that there is an entire process that you can use to undertake any retrofit project. And any kind of planning applications should, I think, be telling you which guidance they're going to follow, which standard they're using, what guidance and how they're going to actually carry out the retrofit projects. I think all of these things are the direction of travel of policymakers, so it's important that it's taken into consideration at the planning stage. And just to let you know that even within the LETI retrofit guidance, there are different measurements that you can try to hit. So obviously the exemplar retrofit is going for 40 kilowatt hours per metre squared for a year, and the best practice is you're going to have old buildings that are hard. to retrofit, and so sometimes there's leeway, but it's always all about what energy reduction, energy demand reduction can you make by doing the project. Yeah, and I've thrown this in there for anyone who's starting out and doesn't realise that there's lots of new build standards. So although it's not retrofit, you would think that these are the standards that are being used to operate and design buildings currently. There's probably going to be a whole host of retrofit guidance that comes out for each of these standards. So start there. If you're starting out and you're learning, these are all the different standards that currently exist in construction for the new builds. So our low carbon learning programme, it's just to give you a kind of overview of the webinars that you can get online for free. They're really good, they're really bite-sized, an hour long, really easy to understand. If any of you would like some practical training in the factory, get in touch. I'd love to show you around and get you working on the rigs. We also have a really brilliant Nidri Road retrofit module, which is a traditional tenement building. So it's where the Housing Association have bought 6 tenements. They're currently doing it to Retrofit standards. And it's just a really good example of the things that you might want to think about for traditional building detailing. We also use the AR and VR headsets, so it'd be good to get you to come in and have a go of those. And this is a really interesting innovation we've got at the back of the factory, where we're trying out different cladding methods for different retrofit projects. So we've actually got a space where you can trial different methods. So it's just really good to be able to get somewhere where you can experiment. And it's not just about trying it out on the actual building, it doesn't work. So all of that you can come and access at the factory. This is just all the cool stuff we've got. I'd love to show you around. We've got robots, we've got the UK's only CLT press, we've got 3D printing. So yeah, if you haven't booked on the tour, come along. And this is our Factory 2.0. So this will be where our deep retrofit centre of excellence is. That's the building on the right. If any of you have any ideas of what you'd like to see in the space, of things that would help the industry or help the public sector, please let us know, get in touch. We're just deciding what's going to go in there now, so we'll get in early. And a few of you had mentioned on the sign up that you wanted to know more about heat pumps and kind of low carbon technologies, because there's other tech that you can use. So we have Heat Source, which is our low carbon heat network. We've got an event here at the centre happening next week. If you want to come along and speak to people, find out about the technology, then just sign up. It's not just about heat pumps. There's other things that are happening. There's heat networks. So yeah, come along and get involved. And finally, just a flavour of what's on our website. So these are all the different modules that you can access for free anytime you like. So yeah, have a look on there. If there's something technical that's come up and you want a little bit of help on, we've probably got it on our website. So just have a look. And that's me. Thanks very much for listening. That's just a couple of events that I thought you might be interested in. So I'll follow up and forward on the presentation, and I look forward to your questions. Thanks for listening.
Brilliant. Thank you very much, Sarah, for that. Just aware of the amount of things that we were covering during that presentation. So I will be
just a quick introduction. So my name is David Coulter. I'm a principal engineer and I'm a certified passive house designer. And with me is Michael Bill, who's a senior engineer, who's also a certified passive house designer. So we're actually part of the MEP team in Baker Hicks. So a rough plan that we've got is just to go over a bit about Baker Hicks in general, kind of who we are, and then we're going to talk about both passive house and Retrofit projects that we've currently got on our books, and what we've kind of learned and kind of key points, what they've been going forward. So firstly, kind of who are we? We are a consultancy firm, but we're under the Morgan Sindall Group. May have known us as MSPS in the past. We've since rebranded as Baker Hicks, and we have 13 offices in the UK and Europe. So 6 are in the UK, 7 in Europe. The DAC region is our European offices, which mostly deal with life sciences projects, whereas in the UK we've kind of got a mixture of everything, from public sector right through to life sciences as well. So we are multidisciplinary. We've got over 1,000 employees. The figures that are sitting on the right of the screen are slightly outdated, but even with the likes of COVID, etc., we're still looking at a kind of positive kind of growth with the company. So what kind of disciplines do we offer? So myself and Michael have put ourselves first. So we've got mechanical and electrical engineering. We've also got civil and structural. We've got BREEAM engineers and a sustainability team. We have architects. We've got a BIM department. We also do CDM, process engineering, project management, and also electrical HV. So we offer all these kind of services to our clients as multidiscipline or individual appointment to each project. So we're running through kind of Passive House certified members in the team. So I did mention that we are multidiscipline. So the first 4 members are mechanical engineers who work for the M&E team. We've got Debbie, who's part of the sustainability team. And then on the right-hand side, we have architects. So we've got cross-discipline accreditation for Passive House and Retrofit. And we've noticed there's a big kind of positive to any project going forward where you have multiple disciplines that all have certification. It means that there is still going to be one kind of design lead on the role, but the likes of, if it's your architect, they're then having to maybe input all the PHPP, which is the Passive House Planning Package information. That's pretty much the calculations that get your accreditation at the end of your Passive House or Retrofit project. If the M&E designer is fully accredited as well, we can also influence exactly what's going in, and we can start looking at fine-tuning maybe where the project is going in the right direction or maybe where it's in the wrong. So it's trying to get that kind of level of expertise over multiple disciplines in our company, and that's something that we offer all our clients going forward for projects. So going on just a little bit about our projects, I won't go through every one of these in detail, but just to kind of touch base on what we kind of do, a flavour and where we've maybe picked up some lessons from one project into the other. So we do a lot of life sciences, like I mentioned. It's our DAC region's kind of bread and butter, but we also do it in the UK region as well. The kind of highlight projects, the first one, which is MMIC, which is just next to Glasgow Airport. It was full multidisciplinary, so we had all our teams involved in that project, and we achieved a BREEAM very good. So this was probably just before the kind of Passive House standards were maybe more firmed up for life sciences, but it's certainly something going forward that we've noticed our clients are now starting to kind of reach on to, trying to make sure, like Sarah mentioned earlier about the fabric first approach, can they get that right? And then the rest side of it is all process engineering side, so there maybe isn't that stringent of kind of regulations for that elements of it. Going on to defence work, we do a lot of work with Kinetic. Also, there's a lot of kind of confidential information on that, but most of these works are upgrading existing buildings, and being honest, the majority of these are kind of tin sheds just now, so we are looking at kind of fabric improvement throughout, and obviously try to tailor their energy requirements to suit each building. Now every single building here, even that middle picture for West Camp, shows that there's a lot of different shapes, a lot of different types of buildings, so it's a challenging but quite a good kind of rollout to see what we can do in terms of fabric improvements. We do custodial work. Main project on there is probably HMP Highland, which is based in Inverness. It's a £90 million project, which we are full multidisciplinary, but it's also the first project on the Scottish Prison Services books, which they're looking at their net zero aspirations. So we are essentially creating a path going forward for them for enabling net zero carbon. And one of the items, which is why we felt it was important to mention some of these projects, is they aren't going for Passive House or Retrofit certification, but what they're using is the Letty Guide principles, which Sarah mentioned. They're using Passive House principles, and they're merging as much as they can, making it more applied to their project. Can they get the fabric to perform to its best degree? Can we get building services in that are going to be Passive House certified, which will then guarantee that you're getting a kind of percentage of efficiency and heat recovery? So SPS have identified that Passive House, the Letty Guide, and obviously Retrofit standards are something that they want to carry through into their projects, even though they're not fully concerned about the certification aspects, because at the end of the day, it's kind of form over function for them. It still needs to operate as a prison first and foremost before they look at energy targets, but that obviously is a massive factor going forward for their projects in their portfolio. Education's got a big one for us as well. We have a number of kind of primary schools, nurseries and campuses that we work on. The majority of these all have kind of independent energy targets, But again, we're starting to see clients that are shifting from, a standard school with, natural ventilation, for example, to more looking at passive house and Retrofit requirements for your SFT funding. So if they can get their operational energy below that 67 kilowatt hours per metre squared value, they can then, open up a wide range of funding from Scottish Futures Trust. But also we're now looking at indoor air quality. We've got a lot of projects just now which are BB 101 compliant, and passive house as well is something that they're looking at full mechanical ventilation in their buildings. So we as kind of mechanical engineers are trying to make sure that we can provide a solution that works to the client's needs, and also the full comfort of that school is also met. So then moving on to kind of low carbon passive house and Retrofit projects that we've currently got active. We do have another opportunities coming up, but these are our kind of live projects just now. North Muirton, or Riverside, it's known in the press just now, is a new build passive house primary school. It's aiming to be the first one in Scotland. Fingers crossed, the kind of programme suggests that we're going to be there at the kind of first passive house primary school. And we've actually worked with Perth and Kinross Council to get their client ACRs up to speed with what passive house is and what is the kind of lead energy targets that we should be focusing on as a design team. So we assisted with them to get their SFT metric below the 67 kilowatt hours metre squared, and they're actually targeting 45 going forward due to the lessons learned on this project. So although it is the first, it's then setting the kind of benchmark and path going forward for future projects on PKC's portfolio. Western Primary School is a kind of conceptual design that we're looking at just now. It is going to be passive house or Retrofit, depending on what option that the client goes for. But it's a retrofit of a two-storey school with a new teaching space added onto it. And again, that's looking at the SFT LEAP funding for phase 3. And Sensify is a full Retrofit certification. Again, it's going to be the first Retrofit primary school project in Scotland. I'll let Michael touch on later on a bit more detail about this project, but the main one for us, it's an SFT Pathfinder project. So again, there's a kind of common theme here that these are all set in the kind of path going forward on how we basically achieve these targets, and hopefully we can then learn and grow from this going forward on all projects with each client. So touching base on the passive house principles, Sarah did mention into it about what passive house is and what we are trying to achieve out it. Now, I did speak about us being M&E designers, so for us, it's not just purely being about the mechanical side of it. We're not just looking at putting in a boiler or an air handler unit. We're now looking at alternatives. Can we put in heat pumps? Can we look at full mechanical ventilation into the system? And how do we get the best performance out of that building? Now, the first kind of principle that we want to talk on is what classification we're going to go for. Now, there's 3 versions of it. You're looking at Classic, there's Plus, and then there's Premium. Each one gives you a certified value, but we tend to see that the majority of the projects will start out at Classic, and then as you apply your renewables, you could then start reaching above to the kind of Plus and Premium packages. Again, that's purely for your certified passive house range, but Retrofit's got the exact same standard. It's just the criteria is a little bit more relaxed because of obviously the constraints of having an existing project or a retrofit project. And then at the end, once you get your certification, you'll have a wall plaque on your building to say that it is fully certified by an external governing body. So what are the kind of key factors? For us as engineers, we're talking more and more about fabric and how buildings are made, which is kind of unusual for ourselves. It is a kind of uncharted territory for an engineer, but it's something that as long as we know that the building is performing to its maximum performance criteria level, then we can then use our services and size them to suit. We don't want oversized services anymore. We don't want to have boilers sitting in 50% oversized or maybe have an extra couple of boilers that are there for backup when really you only really need one for resilience, whereas the other one will probably just sit stagnant. That's what we're not trying to kind of going forward. So we're looking at form factor, orientation, air tightness and fabric performance. They are the key kind of areas to get in fabric first. If you're not thinking about these at the early design stages, there's going to be a lot of catching up to do later on in the REBA stages, especially as us as designers. As mechanical engineers or electrical engineers, we're often asked, how can we offset this? How can we meet these energy targets coming back up? And the majority of the solution isn't good because you're then looking at bolting on technologies. And that's something that we're trying to avoid here. We want to make sure that the building is performing to its peak value at the beginning, and the renewables at the end are then topping up what we need. We're not using or we're not relying on renewables to get us over that kind of compliance line, which I'll be honest has been a historic issue going back to the days of kind of biomass fuels, etc., where there was no real regulation on them. They were purely just flung in to get that green tick in the box. So it's a kind of new mindset for us as engineers. We're also getting involved a lot earlier on because of this, but it's good that we're managing to stress test these buildings, but also see what's possible going forward. So on the right hand side, there's the kind of red tab is mostly what our focus is for form factor, and that's also what is purely about your SFT funding. If you're looking at getting that 67 kilowatt hours, you really should be looking at your low energy use and what kind of measurement and management you're doing of building services or anything that you're going to put into the building that's going to cost money and essentially be there to use for utilities, etc. So going through what is form factor. So form factor is pretty much the building shape and how it's required. For passive house projects, the more rectangular or square the shapes, the less junctions you have, so the less opportunity for loss. So for us, form factor is a key item if we want to make sure that this building is going to perform to its its greatest potential. But it's not always the kind of case there, because there is a bit of function that's required as well. Orientation, we are looking to make sure that we've got the best performing building through using the sun's energy. We want to use as much of that as possible, but we also need to be wary that there's overheating risk. We've also got air tightness, so making sure that that building is then as tight as possible. And then fabric performance falls on the fabric first approach. We want to make sure that the materials that we're specifying are the best performing U values that are there to make sure that that building is fully airtight, fully sealed, and it's not going to be reacting to its environmental conditions. We're not losing a large amount of energy. We're trying to retain that energy and reuse as much as we can. So just looking at form factor against some of our current projects, we've got a T60 block, which is tend to be used in custodial projects, which is got its kind of its cross shape. So that has quite a poor form factor because of the amount of junctions that are in it. We've got HMP Highland, which as I'd mentioned is looking at the kind of low carbon principles and aspirations. As you can see, there's a lot of junctions there with it, but it's purely functional because we need to have a kind of prisoner block or accommodation block on the end. We're looking at ADC ASN, which has got a much improved form factor of 0.6. So that's great. 2-story rectangular buildings are perfect for what we're trying to achieve here. And then you've got North Muirton, which has a slightly worse kind of form factor than EDC ASN, but it's more to do with the actual nursery side on it. If that nursery area wasn't there on that bottom right hand side, we would probably sit in it okay. So there's a wee bit of lessons learned there. Could we have extended the building out to the right and had the nursery in that section? There's kind of thought for process there. But if you look further down to the kind of lower 0.2s and 0.3s, this is what we're trying to kind of achieve for a very good form factor, is almost multiple stories on this kind of same level with as minimal junctions as possible. So the kind of core values then for us for the orientation is making sure we're working north to south. We're going to try and maximise the solar gain, but we're also not going to introduce a large element of overheating. We don't want to have large glazing on the south side that's then going to really heat up the building, and we're going to then have to introduce cooling. We're wanting to use as much of the natural kind of energy as we can. Air tightness through low U values, through low air permeability rate as well. And again, these are all the standards that Passive House and Retrofit set. If we can achieve these, the building's going to perform to its kind of greatest potential through that fabric first approach. And then looking at the actual fabric of it itself, you've got the materials that we're using, the junctions and the service penetrations, which is a big one for us as engineers. We're trying to limit the amount of penetrations that we've got going through that building, because the tighter that fabric, the better it's going to perform and the better it's going to hold in its energy. In the past, engineers, be critical of my own kind of own side of it, we might have multiple drainage stacks, we might have multiple air handling units with ducts, etc., that will punish through the kind of roof. We're going to try and avoid that, and if we can try and contain that in a void before it goes through, try and combine as much as we can. So you've only really got a handful of kind of penetrations that need sealed, rather than having that almost kind of pepper pot top roof where there's going to be multiple opportunities for heat to escape through the building. So again, touching into the numbers, I won't go through all these in kind of a lot of detail, but the key focus is obviously these red figures here. Now, these are the projects that I've mentioned previously, compared against the Scottish building regulations. Just now, they are kind of due to change, but if you look at the air permeability, for example, the building regs, you can get up to 10 or 5 or 3. we're looking at 0.6 for the likes of North Newton, the primary school. So there's a massive difference there of, build quality and making sure that that air tightness level is maintained. There's a high focus on thermal bridging, whereas just now in the current regs, it's not really a focus point. It's, you must kind of try and avoid, but for Passive House, we're trying to make sure we're eliminating as much as possible. The form factor, again, there's really no regulation to it, but again, Passive House has certain form factors that you must adhere to, or you're looking at offsetting it through other means. And the only other mean that we can then look at then is your U values on that left-hand side. So your main ones there, you're looking at your roof, a U value of 0.1, your glazing is 0.8, which is a very low kind of U value, and a G value to also have some solar control for overheating. So every single item there is all a massive kind of step to improvement over the Scottish building regulations, but that is for Passive House. Again, Retrofit is slightly relaxed, but there's still that kind of high performance onerous on making sure you're getting the best materials possible putting into the building and making sure it's as tight as it can possibly be. So just a kind of food for thought on what we've just touched on. The Eastern Banter Council ASN school that we're working on just now. On the left was the concept design that we had. Now, there was no real requirement for us to go down Passive House. In general, the principles were there. When the original concept came, we were looking at a kind of CHP and PV strategy. We were also looking at the infrastructure for the gas and the electricity to come into the building. And then looking at that kind of building just now, going back to some of the previous form factor slides that I had, there's a lot of kind of junctions there. There's internal courtyards. So what they decided to do was almost, merge the building into multiple story. So the image on your right is now what we've came to and what we're working on just now. It's currently on site. But that shows that there's a massive improvement over there, purely by using principles going forward. And that was what we touched on at the beginning of the presentation. We've got a number of projects just now which are not fully certified, or we're not aiming to get certification. But if you're looking at the principles and keeping them within your cost constraints, or maybe your space or buildability, there's still a lot of improvement work to be used through the LETI guide principles, the Passive House and the Retrofit going forward. So that's one instance where we've made massive improvements over the current design that we had, or the current scope and the current brief that we were given by the client.
I'm Michael from Hicks. I'll take you through some of the sustainability and Retrofit requirements. So basically, what is Retrofit? As David and both Sarah have touched on already, Retrofit is the Passive House retrofit standard for refurbishing and retrofitting buildings. As I've already touched on, it's not as stringent as your traditional Passive House requirements, but they are still far in excess of your traditional building regulations. So, for example, your Passive House energy in use consumption is 25 kilowatt hours per metre squared per year. In comparison, your Passive House standard for that is 15 kilowatt hours per metre squared per year. So, like you're doing with your Passive House, you're looking to totally minimise your heat losses, reduce your thermal bridging as much as possible, and just totally try and make as as energy efficient building as possible. Retrofit within the UK isn't particularly new. The first Retrofit certified project within the UK was 2009 to my knowledge. A project called Grove's Cottage, which is an 1869 build cottage that was retrofitted to Retrofit standards for the budget around 140k at the time. So that's probably increased in today's market, but that's a rough estimate of initial projects there. So the key principles at Retrofit, again, comes back to that fabric first approach. Obviously, with an existing building, you're constrained with your existing form factor, orientation, things like that. You're constrained there, so you maybe not have full scope to change certain things, but doing certain tricks that we'll talk about later on, you can try to overcome them and improve your form factor that David was touching on. So basically, you're looking for an air tightness of 1 within a passive house, which is still well under any of the building regulations you're working to at the moment, even in new builds. Again, you're looking at, you know, high quality glazing. Essentially, you will require triple glazed glazing within passive house or Retrofit projects. There's just no getting away for that, just to achieve those sort of high air tightness rates and minimise your heat losses and thermal bridging. Your ventilation units, David says, you know, they're key. Basically, for Retrofit or passive house, if you're going for certification, you'll be looking at using certified units. And then you can obviously integrate renewables to further improve, you know, the energy performance of the building. Looking at, you know, plus and premium, as we touched on earlier on. So yeah, your main sort of constraints for your existing buildings are, you know, your existing architecture. What can you really change? As I said, you can't really touch on, you know, changing the orientation. If your building's facing fully south and it's got a lot of glazing south, is there options to potentially reduce the heat gain over your summer months? Can you use some sort of external shading, or is it, you know, a case of blocking up some windows? But then you've got the case of planning and conservation issues that might impact that. These are intertwined, and these will vary on a case-by-case project to project basis. Your existing utility infrastructure, is there any scope to, you know, and integrate the thing within a district heating network, for example? A lot of these buildings that we're working on at the moment are all going down, you know, the full electric route. You potentially need to look at, you know, increasing the network capacity within the area, the supplies to the building, to go down that route, to integrate heat pumps, to, you know, power these MVHR units that are required. As I touched on earlier, your windows and door strategy, you're looking at, you know, a minimum of triple glazed windows there. Your plant constraints are a big one that we've found so far in the Retrofit projects. Typically, we've got a couple of 60s builds that David touched on earlier, the St. Sophia's project and the Westerton project. And some of the ceiling heights at the moment are constrained to sort of 2.7, 2.8 metres at the moment. And you're not going to be able to run massive amounts of services down corridors to integrate this ductwork into a classroom. So there's strategies that we can look at and essentially overcome these, and we'll touch on these later in the presentation.
Okay, so I'm going to just quickly touch on the first kind of passive house new build that we're looking at just now in terms of primary schools in Scotland, which we talked on earlier, was North Muirton Primary School. So it's a £50 million project. It's a new build for Perth and North Council. It's a tandem build, so we are working with the existing primary school outline, and they're currently working on that just now. So as I mentioned earlier, we did talk about the ACRs. We helped the client almost set up their own ACRs going forward as their kind of benchmark standards. We've reviewed the energy targets with the kind of Scottish Government, LEAP funding and your SFT funding. Michael's touched on there about the electrical infrastructure. Being reviewed for the kind of full electrical option, which we managed to get. The original project had gas put into the kind of main scope. The client was very keen to remove any type of fossil fuel, which again is a really good kind of factor for us going forward. But we also need to consider what kind of supplies we've got going in. We're then looking at outperforming the SFT metric of 67. So it's not just a case of that's what we need to achieve to get our funding. They're trying to say, you know, how far can we take that further down, because the lower this building actually operates, the better it's going to be for our own benefit, the end up quality of install that's going to be required, but also the more comfort for the kind of end users, which in our instance is pupils. mentioned that the ACRs, that's the construction requirements. So that's purely just how the contractor is going to build this project, but also how we're going to then maintain it. So it's once you put in any form of energy, how do we use that energy? How do we meter it? How do we monitor what it's meant to be doing? It's almost like a set of regulations for the contractor, the design team, basically anybody that the client's going to appoint on the project. As long as they can conform to these ACRs, that project will run exactly what we're meant to do as a benchmark. Passive House and Retrofit have their own in terms of the PHPP pack, which is us basically putting in all their figures that we are going to expect the project to perform to. At the end, it will then tell us that it's going to meet a PER value, which then tells you that you're going to have your set energy target of X and Y. So ACRs is purely to make sure we're on track to it, but it's also more a specification type for the client to come back and say, we need to have this type of material, we need to have this type of application. So something like an MVHR must be certified. That's almost a client requirement, but it's also a Passive House certification requirement. So going on to the kind of actual energy usage. So the table on the left is a Section 6 compliance. That's how we normally run our projects up until now. There's a lot of kind of thermal demand, small electrical demand. But then when you look at how we would then model a TM54, which is your in-use energy model, we are then noticing a large increase in electrical demand, but then we're also noticing that that thermal demand is also increasing because we're putting in actual operational usage profiles. When you compare that against an SFT and a Passive House project, you see that your electrical usage then goes up, but your thermal is coming down massively, and that's purely because the fabric's doing its job. The fabric's maintaining that energy. We're not having these boilers or heat pumps running at full pelt non-stop to try and catch up with what the temperature then inside needs to be to match the external conditions. So that kind of shows the difference there. And also we put in a kind of bar just to show where North Newton's looking at, and also the future targets of 45. That's what PKC are hoping to aim for all their future projects going forward. So a little bit again about Passive House. So for North Newton, this is the kind of original concept design for it. We're looking at optimizing the orientation. So although it's a tandem build, we've managed to make sure that the space that we've selected for the project gives us the best performing orientation. We're looking at MVHR units. There's multiple in the project serving all the floors, but every single room in that building is mechanically ventilated, which is another requirement for Passive House. But we're also making sure that because the MVHR units are certified unit, we're getting up to 92% efficiency on that unit. So the heat recovery uses a counterflow plate heat exchanger, which is purely making sure that we can get the best out of that unit. And that's one of the things, certainly as a design engineer, we need to make sure that our specification has that to get that certification from Passive House at the end. The kind of implications for ourselves as designers, early engagement, I would say, is probably the best. You know, all this stress test and all the information that we're showing just now was only achievable because we as an M&E designer and other disciplines were on board at a very early side of the kind of concept stage. You know, traditionally we'll be brought in at kind of REBA 1, REBA 2 to give kind of high level estimates or high level, you know, this is how we would serve this building. Whereas just now we are essentially stress testing that 2 stages before when we are traditionally meant to do that. So kind of proof of that is this was our stage 1 modelling. Now stage 1 to us is normally single line drawings to show that here's a bit of plant and this is roughly how we'll serve it. As you can see, this is a fully modelled 3D ductwork layout in Revit, and that's to show the extent of the mechanical supply and extract ventilation that was going to be required. We have adopted software within Baker Hicks to kind of make our lives a little bit easier through the sizing to make sure that it's all going to fit. But like Michael mentioned, you know, this is good for stage 1 concept side of it on a new build, but on a existing project where you're trying to maybe shoehorn in ductwork, this is a key kind of factor that we need to make sure that if we're going to go down an Retrofit route, we can get these MVHRs fit into the building and we can get all the associated ductwork to fit as well. And that's just some kind of live site photos that we've got as of last week. On the left hand side, you'll see that's your MVHR. Now that's purely just to show the scale of that. You know, these units, they are highly efficient, but they are very high in dimensions as well. You know, to get this highly efficient kit in, there's going to need a lot more space. Certainly the heat exchanger is almost double what it would normally be. So these kind of things need to be factored in, because they are going to be, certainly in a new build, you're going to need an extra bit of length on your plant rooms. But if it's an existing build, having a unit that size, not to say that that's the size that all of them are, this is quite a big scaled unit, but it needs to be considered going forward, and that hopefully as M&E designers, that's what we should then be telling clients and the likes.
As we touched on earlier, one of our projects at the moment is the Sensifiers project that some of you might be aware of from previous presentations. From HBS, who's the architect we're working alongside in this one. So it's with East Ayrshire Council, and the Retrofit accreditation was a requirement from the client for the outset. Initially, we embarked on a two-stage tendering process for this, whereby a contractor was appointed early, with the theory that they're going to assist the development of the construction information. Given market forces at the moment, the council was taking the decision to revert back to a traditional approach. So that project's currently being revised to incorporate that, and should be going to market in January, I believe, as per the current programme. As we touched on earlier, it was initially programmed to be the first Retrofit school within the UK. At the moment, I think we're still on track to be the first Retrofit, definitely within Scotland. I think throughout the UK wide, we might just fall short of that initial target. So initially, there was over 70 different external facades within this small, circa 1,200 metre squared school. Chimneys, water tank towers, wee niches. Like, it really, the form factor was really, really poor. So the architect has initially, done some high level plant, overall sort of building massing modelling in order to try and achieve a sort of fairly reasonable form factor for given the building constraints that we've got. So that included, demolition works to these sort of areas. Demolished a toilet block. We added some extensions, and the images you can see on screen are the sort of final proposals of that. Probably the sleekest that we could have got this building given the constraints that it initially had. Thought something key to touch on with this is this will be a full decant of the school. The kids won't be in here at all while this is ongoing, which is sort of in contradiction to the Retrofit one that we're looking at for Western Primary at the moment, where a phased approach is currently the preferred strategy of the council, and that obviously brings its own challenges with a live construction site while trying to achieve really high construction performance figures with your air tightness on projects such as this. So Sensifiers, going back to Sensifiers was like an initial, Pathfinder project for SFT. It was supposed to be delivered within, the SFT funding matrix. So obviously budget constraints, and probably hence why the council has decided to go to open market with us now, as opposed to the two-stage procurement approach, which tends to have a sort of higher premium attached with it. So given the constraints of the existing building, low ceiling heights, a centralised MVHR option, as David showed at North Muirton, wasn't really an option for this. So we had to explore options and what was feasible. So we went down the route of a decentralised MVHR style approach. Each of the classrooms have got their own certified MVHR units, which gives, good controllability. Classrooms aren't being ventilated if they aren't occupied and in use, all monitored in CO2, in accordance with BB 101 and excess of that, if we're honest. It's all they're all designed to sort of operate at 800 ppm at absolute maximum. Similarly with the hot water, we've went down a decentralized approach with that as well, whereby essentially we're running a mains cold water round the school, and then locally provide generating the hot water via point of use water heaters. This is a sort of passive house approach strategy to providing hot water. It removes distribution losses greatly in comparison to traditional calorifiers within plant rooms and then distributing round. The infrastructure for this site required to be totally upgraded. Basically, new incoming electrical supply, existing gas supply removed. We're going all electric. It's now served from air source heat pumps. And a new water supply was required as well to provide fire hydrant coverage for the site. And basically, to touch on sort of any lessons learned for this one, our advice to clients going forward would be to, as David already mentioned, appoint your consultants early, but at the same time, spend the money and get an accurate point cloud survey at the project's inception, so that you have a accurate to a few millimeters model of the site that you're hoping to retrofit, and that really pays dividends going forward throughout the project. So there's sort of key takeaways from this towards the sort of left-hand side of that pie chart there. As you can see, traditionally designers are really sort of focused in on the low energy and then the sort of measurements in line with your SFT funding. Whereas going forward, we can see it starting to happen more often with clients now. The embodied carbon's becoming a lot more a key thing and key requirement for clients. So it's something that we as designers are starting to take on board more. And then there's that sort of decarbonisation in the grid. So as air source heat pumps or ground source heat pumps or things like that, are they going to be the only method we're going to be using for going forward? It's probably not. There'll be a case for varying technologies depending on the project and its requirements as we try and achieve those net zero goals. Operational energy is really, that's the sort of key driver behind all this. Both Sarah and David have already touched on the sort of SFT requirements of this. So SFT funding works on a sliding scale, whereby you achieve that magical 67 kilowatt hours per metre squared per annum for your energy and use, and the Scottish Government will provide 100% of your funding towards your new build school. That works on a sliding scale up to about 120 kilowatt hours per metre squared per annum, if I'm correct in my memory. And then after which, basically the local authority has to provide any additional funding themselves, essentially. So operational energy, and what is it really? So like your associated distribution losses, going back to your sort of point of use water heating just touched on. That's why we've went down that, to try and minimise the distribution losses associated with generating hot water and serving appliances throughout the building. Lighting has been one that's been there for a while. If you think of schools and anything like that, they've had PIRs in them for a number of years. Obviously, occupancy detectors, daylighting, all those energy saving measures. That's what councils have been using for a number of years to try and reduce their operational and use energy performance. And as you can see, the 15 kilowatt hours per metre squared per annum is the sort of passive house targets, and that's really the driving force behind passive house stroke Retrofit. The ability to target these sort of low energy in use and actually, hopefully achieve that, as opposed to the performance gap that's widely publicised throughout the industry. Passive house and what it really means to contractor, end user, client. It's essentially it's a different way of thinking. Typically within the UK construction industry, there can be a bit of conflict between, you know, designers, contractors, clients. Collaboration is really what the kind of heart behind passive house methodology is. So it's, you know, having that early engagement within the design teams. David said, you know, the engineers are getting involved earlier than we ever have done traditionally within projects. You know, that sort of teamwork, and we integrating with architect, integrating with the client, a two-stage to the, you know, a procurement approach to get the contractors' thoughts on board early. That can all have benefits, and that can only, you know, ultimately help the client at the end of the day. So obviously myself and David are both certified passive house designers. You also get, you know, certified construction professionals on site. So that can, you know, whittle right down to something like the contractor having an accredited air tightness champion on site who will take responsibility for ensuring that what is installed on site is what the design is really asking for at the end of the day. And it's that sort of whole life approach to these projects as well, that's really key. One thing that comes up quite a bit is the sort of maintenance aspect to these buildings, and that's something that we see our clients and their sort of term maintenance contractors need to become aware of, and it's that training, upskilling that's all important. You know, we're working hard to get these buildings airtight. A contractor can't just come along and, you know, start penetrating that air tightness layer anywhere they deem fit. You know, these are all things that in use that as this becomes more mainstream, you know, it's definitely an upskilling of everyone across the industry. And just say thanks very much for your time, and really pass over